If your child is considering something as big as joining the military, you can bet they're taking the time to do some research. You can too by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
It's important to properly dispose of unwanted medication or sharps. MedProject offers free and convenient disposal options near you. To learn more, call 844-MED-PROJECT or visit medproject.org.
This is SpaceTime, Series 24, Episode 114, for broadcast on the 8th of October 2021. Coming up on SpaceTime, Bepi-Colombo's Mercury Flyby underway, the planet Jupiter hit by something really big, and Beijing's new spy satellite lost in space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
As we go to where, the joint European Space Agency Japan Aerospace Exploration Agency Bepi-Colombo mission to Mercury is undertaking the first of 6 flybys to its destination planet as it uses the tiny world's gravity to slow down enough to eventually achieve orbit insertion in 2025. The first Mercury gravity assist braking maneuver follows hot on the heels of the probe's Venus flyby in August. The Mercury maneuver is swooping down just 200 kilometers above the surface of the 4,700 kilometer wide planet, in the process capturing imagery and science data that'll give researchers a tantalizing first taste of what's to come in the main mission. The Bepi-Colombo mission comprises 2 science orbiters, which are being delivered into complementary orbits around the planet by the Mercury Transfer Module. The ESA-led Mercury Planetary Orbiter and the JAXA-led Mercury Magnetospheric Orbiter will study all aspects of this mysterious inner planet, from its core right through to its surface, and even its magnetic field and the exosphere surrounding the planet, in order to better understand the origins and evolutions of this tiny world, the nearest rock to the Sun. The Bepi-Colombo mission's making use of 9 planetary flybys in total. There was 1 of the Earth, 2 of Venus, and now 6 of the planet Mercury. Together with the spacecraft's solar electric propulsion system, it'll help steer the stack into Mercury orbit. These gravitational flybys require extremely precise deep space navigational work, ensuring that the spacecraft is on the correct approach trajectory for each encounter. In fact, 1 week after Bepi-Colombo's last flyby of Venus on August the 10th, a correction maneuver was performed in order to nudge the spacecraft just a little for its first Mercury flyby. The spacecraft is flying exactly 198 kilometers above the Mercury surface. The flyby comes as Bepi-Colombo is more than 100 million kilometers from Earth, with signals from mission managers taking some 350 seconds, that's about 6 minutes, to reach it. High-resolution imagery using the spacecraft's main science camera can't be taken during these flybys because the equipment is shielded by the transfer module during the mission's cruise configuration. However, 2 of Bepi-Colombo's 3 monitoring cameras have been taking images during both the close approach and extended departure phase of the flight. Because Bepi-Colombo is swooping down over the planet's night side, conditions are not ideal to take images directly at the closest approach. And so the closest images will actually be captured at a distance of about 1,000 kilometers. These cameras will provide black and white snapshots in 1024 by 1024 pixel resolution and are positioned on the Mercury Transfer Module so that they also capture the spacecraft's solar arrays and antennas. And as Bepi-Colombo changes its orientation during the flyby, Mercury is seen passing behind the spacecraft's structural elements. Despite the distance, the closest images can still identify large impact craters on the planet's surface. Mapping the surface of Mercury and analysing its composition will help scientists better understand more about the planet's formation and evolution. Even though Bepi-Colombo is still in its stacked cruise configuration for the flybys, it'll still be possible to operate some of the science instruments on both planetary orbiters, allowing a sort of first taste of Mercury's magnetic, plasma, and particle environments. And the timing is all rather appropriate as well. See, the first Mercury flyby has fallen on the 101st anniversary of the birth of Italian scientist and engineer Giuseppe Bepi-Colombo, who was born on October 2, 1920. Colombo was able to explain Mercury's rather peculiar characteristic of rotating on its own axis 3 times for every 2 orbits of the Sun. He was also the scientist who first realized that by careful choice of a spacecraft's flyby point as it passed a planet, that planet's gravity assist could help the spacecraft make further flybys, either slowing down or accelerating the spacecraft depending on the exact angle of approach. It was his interplanetary calculations which enabled NASA's 1974 Mariner 10 spacecraft to achieve 3 flybys of Mercury instead of 1, by first using a flyby of Venus to change the spacecraft's flight path, the first of many spacecraft to use such a gravity assist maneuver. Following Mariner 10's mission in 74 and 75, NASA's Messenger spacecraft flew by Mercury 3 times over 2008 and 2009, before finally achieving orbit insertion for a 4-year mission between 2011 and 2015. This is SpaceTime. Still to come, the planet Jupiter hit by something big, and a new Chinese spy satellite lost in space. All that and more still to come on SpaceTime.
New on CuriosityStream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
Citizen scientists observing the gas giant Jupiter on September the 13th got more than they expected when they witnessed a giant flash of something suddenly slamming into the planet. The impact flash, which lasted around 2 seconds, was seen from both sides of the Atlantic Ocean by at least 9 observers. Early estimates suggest the impactor would have been a stony iron asteroid about 20 meters in size. The structure of the flash shows that it brightened, faded, and then lightened again, which is signatures of an impactor fragmenting in the planet's upper atmosphere. Of course, it's not the first time people have seen something big hit Jupiter, but that doesn't take away anything from the spectacle of the event. The first direct evidence of extraterrestrial collisions occurred back in 1994 when the comet Shoemaker-Levy 9, which had already broken apart into several dozen chunks following earlier encounters with Jupiter's massive gravity, was seen to impact Jupiter in a series of spectacular collisions, leaving a series of dark scars in the Jovian cloud tops, each as big as the Earth, and which lasted for months. The observations were a wake-up call for politicians, who finally heeded the advice of scientists and began an active campaign to record, monitor, and characterize comets and asteroids in near-Earth orbits. Of course, since then, people have seen multiple objects crash into Jupiter, and undoubtedly many more are occurring unnoticed. This is SpaceTime. Still to come, Beijing confirms the loss of a classified military spy satellite that was spotted flying over Australia's east coast last week. And the Alpha Centauri star system, the Large and Small Magellanic Clouds, and 3 separate meteor showers are among the highlights of the October night skies on SkyWatch. Beijing has now confirmed the failure of a new classified military spy satellite that was spotted flying over Australia's east coast last week. The 5,500-kilogram Xian-10 was launched aboard a Long March 3B rocket from the Xichang Satellite Launch Center in southern China's Sichuan province. Sightings over Sydney and the New South Wales Central Coast showed that the launch vehicle's upper stage was performing as planned. And data from the United States Space Force's 18th Space Control Squadron indicated a successful payload separation into a 177 by 40,105 kilometer high geosynchronous transfer orbit. However, while the satellite successfully entered orbit, there was no follow-up confirmation that it was operating nominally. The cause of the failure remains unknown. The mission was the second launch for China in the space of 2 hours. Earlier, Beijing had successfully launched a Kuaizhou 1A rocket from the Jiaquan Satellite Launch Center in northwestern China's Gobi Desert. The 20-metre-tall 4-stage solid-fueled rocket successfully delivered a new Xiaoling 1 Gaofeng 02D Earth observation satellite into a 545-kilometre high orbit. Beijing says the spacecraft will be used to monitor crop yields, urban growth, forestry operations, and agriculture. The spacecraft will also provide high-resolution sub-meter and multispectral resolution optical imaging of the planet as part of Beijing's ongoing efforts to provide near-continuous high-resolution monitoring of areas of interest to China, including the South China Sea, Taiwan, China's border with India, and the military activities of nations like Japan, South Korea, and the United States. To achieve this, Beijing's launched more than 138 Earth observation satellites in the past 5 years, including at least 31 Gaofeng and some 84 Yaogang spy satellites. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for October on SkyWatch. October is the 10th month of the year, and that may seem confusing since octo in Latin means 8 rather than 10. The answer lies in the old Roman calendar, which had just 10 months before the addition of January and February. And that 10-month year is still reflected today, with the name September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. Of course, the highlight of October for kids and those who are young at heart has to be the last day of the month, celebrated as All Hallows Evening or Halloween. Halloween is based on ancient Celtic pagan festivals such as Samhain, the Gaelic festival of the dead. Samhain was eventually Christianized by the early church to become All Saints or All Hallows Eve, or simply Halloween. It's a time when darkness overtakes the light of day, a reference to the increasing hours of darkness as the planet's northern hemisphere moves towards longer winter nights. And so it's a time when the harvest comes to an end. The increased hours of darkness mean the boundary between the world of the living and the world of the dead becomes especially thin, allowing the dead and supernatural to rise in search of the living. And so the living wear disguises so as not to be recognized by the dead. And it's this which has led to today's tradition of the Halloween fancy dress party. In some parts of the world, cross-dressing is popular on Halloween, a reflection of the secret desires and fantasies of their pagan ancestors, sometimes not so many generations removed. To ensure that crops and livestock survive the cold winter months ahead, offerings of food and drink would be left outside for the spirits and fairies of the other side. And it was this which ultimately led to today's practice of trick-or-treat. Also, candles would be lit and prayers offered to the souls of the dead, as Halloween was a time when the spirits of the dead would return to their former homes. Special bonfires were also lit on Halloween to light the darkness, thereby preventing souls of the dead from returning and keeping the evil away. The flames, smoke, and ashes were deemed to have protective and cleansing powers and were used for divination. As for the tradition of carving pumpkins into jack-o'-lanterns, well, that was originally meant either to represent spirits or supernatural beings, or alternatively to ward off evil spirits. In many parts of the world, the Christian religious observances of All Hallows Eve include attending church services and lighting candles on the graves of the dead. And Christians historically abstained from eating meat on All Hallows Eve, a tradition reflected in the eating of certain vegetable foods on the day, including apples, potato pancakes, and soul cakes. Apple bobbing originated because the apple was a Celtic symbol of love, and so grabbing the apple with your teeth had certain erotic overtones. Halloween is a time of fortune-telling and divination games, playing pranks to scare people, visiting haunted attractions, telling scary stories, and of course watching horror movies. Looking to the southwest, you'll see the two bright pointer stars, which show the way to the Southern Cross. The brightest, and what also looks like the more distant of the two stars from the Southern Cross, is Alpha Centauri, which is actually the nearest star system to our own solar system. Alpha Centauri is a triple star system comprising two stars, Alpha Centauri A and B, which orbit each other in a binary, and a third star, Proxima Centauri, which orbit the pair. Like the Sun, Alpha Centauri A is a spectrotype G yellow dwarf star. It's about 10% more massive than our Sun and about 1.5 times as luminous. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectrotype O blue stars. They're followed by spectrotype B blue-white stars, then spectrotype A white stars, spectrotype F whitish-yellow stars, spectrotype G yellow stars, that's where our Sun fits in, spectrotype K orange stars, and the coolest and least massive stars of all are the spectrotype M red stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now you put all that together and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectrotype M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can be up to 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarf stars we mentioned earlier. These can be 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Alpha Centauri A's binary partner, Alpha Centauri B, is a spectrotype K orange dwarf star, a little smaller and cooler than its companion, with about 90% of the Sun's mass and about half its luminosity. This binary pair, Alpha Centauri A and B, orbit each other at between 11.2 and 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which equates to about 150 million kilometres or around 8.3 light minutes. So the pair's orbit around each other varies by between the average distance between the Sun and Saturn and between the Sun and Pluto. It takes the two stars 79.91 Earth years to complete each orbit. On average, Alpha Centauri A and B are located 4.37 light years from the Sun. Now, although a light year sounds like a measure of time, it's actually a measure of distance. A light year is a distance of about 10 trillion kilometres. That's the distance a photon can travel in a year at the speed of light, which is around 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The third star in the Alpha Centauri system is a spectral type M red dwarf star named Proxima Centauri. Right now, Proxima Centauri is just 4.25 light years away, making it the nearest star to the Earth other than the Sun. It is only loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of 13,000 astronomical units, or around 0.21 light years. That's about 430 times the size of Neptune's 30 astronomical unit orbit around the Sun. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting within the habitable zone of Proxima Centauri, making it the nearest known extrasolar or exoplanet to Earth. The habitable zone, which is sometimes also referred to as the Goldilocks zone, is that area out from a star where it's not too hot, not too cold, but just right for liquid water, essential for life as we know it, to exist on a planet's surface. The planet, known as Proxima b, takes just 11 Earth days to complete one orbit around its host star. That's far closer than Mercury's 88 Earth day orbit around the Sun. A few years ago, a second, more distant planet, Proxima c, was also discovered orbiting around the star, but well outside its habitable zone. The second and slightly fainter of the two pointer stars is Beta Centauri, and while Alpha Centauri is the third brightest star in the night sky, outshone only by Sirius and Canopus, Beta Centauri is only about the 10th brightest. Looking to the southeast, and you'll see the bright blue white star Alpha Eridani or Achernar, which represents the southern tip of Eridanus, one of the largest and longest constellations in the sky. Achernar is located about 139 light-years away. It's actually a binary star system comprising two stars, Alpha Eridani A and Alpha Eridani B. Alpha Eridani A is a hot young spectral type B blue star. It has about 6.7 times the mass of the Sun, and a stunning 3,150 times the Sun's luminosity. By comparison, the companion star Alpha Eridani B appears to be a spectral type A white star with about twice the Sun's mass. The two stars orbit each other every 14 to 15 Earth years at an average distance of about 12.3 astronomical units. Because of its high rotation rate of over 16 km per second, Alpha Eridani A is actually one of the least spherical stars in the Milky Way. Spinning so rapidly, it's assumed the shape of an oblate spheroid, with an equatorial diameter 56% greater than its polar diameter. This distorted shape means the star displays a significant latitudinal temperature, with its polar temperature being about 20,000 Kelvin, while its equatorial temperature is only around 10,000 Kelvin. That's because it's much further away from its stellar core. The high polar temperatures are generating a fast polar wind. That's ejecting matter from the star and creating a spectacular polar envelope of hot gas and plasma. Now, if you look up between the South Celestial Pole and Achernar from a really dark place, you'll see two faint fuzzy-looking clouds. Now, these aren't actually clouds. They're two satellite dwarf galaxies which orbit the Milky Way, known as the Large and Small Magellanic Clouds. They're named after Ferdinand Magellan, who became the first European to officially record them during his expedition to circumnavigate the Earth between 1519 and 1522. The bigger and nearer of the pair is the Large Magellanic Cloud, which is located around 160 light-years away. It's easier to spot about halfway between Achernar and the horizon. It's about 14 million light-years across, twice that of the Small Magellanic Cloud, which is located a more distant 200,000 light-years from the Milky Way. Now, by comparison to these two satellite galaxies, the Milky Way is huge, 100,000 light-years across. These two dwarf galaxies are separated from each other by roughly 75,000 light-years. The Magellanic Clouds were considered the closest galaxies to the Milky Way until the 1994 discovery of the Sagittarius Dwarf Elliptical Galaxy and the 2003 confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. The total mass of the Magellanic Clouds is uncertain. Only a fraction of their gas seems to have coalesced into stars. They also probably both have very large dark matter halos. Still, one recent estimate places the total mass of the Large Magellanic Cloud at about 1/10 that of the Milky Way. The Magellanic Clouds have both been greatly distorted by gravitational tidal interactions as they're gradually torn apart and absorbed by the Milky Way. These huge tidal forces have turned both Magellanic Clouds into irregular disrupted barred spiral galaxies. The Large Magellanic Cloud still retains a very clear spiral structure, at least in radio telescope images of neutral hydrogen. But gravity isn't a one-way street, and the combined gravitational force of both Magellanic Clouds is also affecting the Milky Way, distorting the outer parts of our galactic disk. And there are streams of neutral hydrogen gas clouds and isolated stars, connecting both dwarf galaxies to each other and to the Milky Way. A brilliant example of galactic cannibalism at work. Now, if you look just above the Small Magellanic Cloud using a backyard telescope or a good pair of binoculars, you'll see a small blurry dot. That is the 47 Tucanae globular cluster. A tightly packed ball of stars some 16,000 light-years away that were all originally formed at the same time through the gravitational collapse of the same molecular gas and dust cloud. If you look to the west, you'll see the bright reddish-orange supergiant star Antares, the heart of the constellation Scorpius the Scorpion. And above it, you'll see a bunch of stars stretching out shaped like a reverse question mark. That's the tail of the Scorpion. Now, just above and to the north is the constellation Sagittarius the Archer. Sagittarius shows the way to the supermassive black hole at the center of the Milky Way galaxy, some 27,000 light-years away. This monster black hole, known as Sagittarius A star, has about 4.3 million times the mass of our Sun. Now, looking to the north-northwest this time of the year, you'll see the constellation Lyra the Harp, and its brightest star Vega, the fifth brightest star in the night sky, and one of the closest at just 25 light-years away. Vega is a spectral Type A white star, more than twice the size and some 40 times the mass of our Sun. Now, just to the right of Lyra, and almost directly north just above the horizon, is the constellation of Cygnus the Swan, and its brightest star Deneb, one of the most luminous stars in the sky. Deneb is a massive spectral Type A white supergiant, some 19 times the mass and over 100 times the diameter of the Sun. The star is somewhere between 55,000 and 196,000 times as luminous as the Sun. The huge range in luminosity estimate is caused by the difficulty in determining Deneb's exact distance from us. Science's best estimates place it somewhere around 2,600 light-years away, give or take 212 light-years. High in the northern sky right now is the constellation Aquila the Eagle, and its brightest star Altair. Altair is another spectral Type A white star, but located a lot closer, just 17 light-years away. It's about 10 times brighter than the Sun, with about 1.89 times the Sun's mass. Despite its size, Altair spins on its axis in just 10 hours, compared to our Sun's 28 Earth day rotation. Now, these three stars, Altair, Deneb and Vega, form a stellar grouping known as the Summer Triangle. Now, also in October, there are three meteor showers: the Draconids, the Taurids and the Orionids. The Draconids take place on October the 8th. They're so named because their meteors appear to radiate out from the constellation Draco the Dragon, and so are best viewed from the northern hemisphere. They're actually produced as the Earth's orbit takes it through the debris trail left behind by the comet 21P Shihokubini-Zinna, which takes about 6.6 Earth years to make a single revolution of the Sun. The Taurids meteor shower takes place on October 10th, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Their meteors are composed of larger-than-average pebbles and dust grains, and are thought to be generated by debris left behind by the comet 2P Encke. Although it's thought that both the Taurids and Encke could be the remains of an earlier comet which disintegrated over the past 20,000 to 30,000 years, breaking into several pieces and releasing material both by normal cometary activity and possibly also by gravitational tidal interactions with the Earth and other planets. The Taurids debris stream is the largest in the inner solar system, taking the Earth several weeks to pass through and resulting in an extended period of meteor activity compared to other meteor showers, which are usually over in just a matter of days. Now, due to the gravitational perturbations of the planets, especially Jupiter, the Taurids have been spread out over time, allowing separate segments, labelled the Northern Taurids and Southern Taurids, to be observable at different times in different hemispheres. The Southern Taurids are active from around September the 10th to November 20th, while the Northern Taurids are active from October the 20th to December the 10th. The third meteor shower this month is the Orionids, which peak on October the 20th. They're caused by debris from the comet Halley, which also causes the Eta Aquarids meteor shower in May. Comet Halley takes 76 years to complete each orbit around the Sun. It'll next become visible near Earth in 2061. The Orionids are equally spectacular in both northern and southern hemisphere skies, with up to 20 meteors an hour radiating out from the constellation Orion. The best time to see the Orionids is just after midnight and right before dusk. And now, with more on the October night skies, we're joined by Jonathan Nally, editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, we've got the seasons changing at the moment. Both hemispheres, we're heading from one season into another. So from us down here in the south, we're in spring, but heading towards summer, and it's, of course, the opposite up in the northern hemisphere. So for us down where I live anyway, the weather's warming up, and we're heading for a really good few months of summer. I've decided that I'm a summer stargazer, not a winter stargazer. You can see great stuff at both times of the year, but winter's cold and it's cold and rainy and you get a lot of cloud stuff. Summer, it's nice and warm. You go outside, you can go outside in your shorts and t-shirt and just look up at the sky. Oh, that's a picture. Oh. Yeah, thank you. Yeah, the only problem is that, and it's only a small problem, is that the nights are shorter over summertime. But that doesn't matter. It's more than made up for the fact that you've got good weather for stargazing and lots of good things to see. So what can we see in October? Well, way down south, we've got the Magellanic Cloud galaxies. So these are the two nearest sizable galaxies outside of our Milky Way galaxy. They're not that far away in space terms, and they're named the Magellanic Clouds after explorer Magellan, who spotted them. I mean, other people had spotted them before him, but he got his name attached to them. And they're down there, down south, about halfway up from the horizon. If you look sort of straight south this time of year, in the mid-evening, there are two of them, the small one and the large one, and you will need dark skies to spot them. But when you do, you should be suitably impressed, because even though they just look like large, faint, fuzzy clouds, they are actually galaxies, which is pretty incredible. Now, if you're looking for the famous Southern Cross down there in the south and you can't find it, don't panic. You're not going mad, because at the moment it's upside down and either right on the southern horizon or even below it, depending on what your latitude is. So I live in Australia, so for half of Australia we can't see it this time of year because it's below the horizon down there. If you're in Melbourne or Hobart, down further south, you should be able to see the Southern Cross upside down right on the southern horizon. Overhead, the sky seems reasonably empty this time of year, actually, in the evening. There are some big but seemingly dull constellations. You've got Capricornus and Cetus and Sculptor and Aquarius and some other ones like that. And the northern part of the sky also seems a bit devoid of interesting things to see this time of year, or in October at least. In the western sky, we've still got the constellations Scorpius and Sagittarius, which are magnificent. Sagittarius is when you're looking straight into the sort of middle of our galaxy. Scorpius is one of the only constellations that looks like what it's meant to be, this big scorpion shape, which is really quite incredible. But they're going to get lower and lower and lower as the nights pass, and they'll soon disappear from view. But if you do like staying up late or getting up early in this month, in October, there are plenty of things to see later in the night. So after midnight, we've got the Milky Way rising in the east, bringing with it the fabulous constellations Orion, and Taurus, and Gemini, and Canis Major, and Puppis, and all sorts of other ones that most people haven't heard of, but they're really quite amazing. All of them have lots and lots of interesting stars and what astronomers call deep sky objects, things you need telescopes to see, star clusters and nebulae and galaxies and those sorts of things. So, for instance, Canis Major, the one I just mentioned, has the brightest star in the sky, Sirius. Orion has two bright stars, like really bright stars. You've got Rigel and Betelgeuse, and it's got the famous Orion Nebula, of course, which you can see as just a smudge of light with the naked eye if you let your eyes get dark adapted when you go outside. And it looks tremendous through a telescope, but even binoculars gives you a bit of a pretty good view. Above the northeastern horizon after midnight, or in the early morning if you get up before dawn, you'll see the constellation Taurus. And in Taurus, we've got two star clusters, big ones known as the Hyades and the Pleiades. Both of them look fantastic through binoculars. The Hyades is actually, it looks like it's inside a group of stars that look like a triangle or a wedge shape. It's really quite prominent. And you get some binoculars onto that and sweep through that area with binoculars, and it just looks beautiful, all these sparkly little stars. The Pleiades is a smaller cluster. It's called the Seven Sisters as well, and that just looks superb through binoculars or a telescope if you can get your hands on one. It's called the Seven Sisters because for the average person with good eyesight, which is not me anymore, and I'm very average, my glasses don't work that great at night anymore. I need some new specs. But yeah, most people can see 7 stars, and it's actually a good test of your eyesight to see how many stars you can see in this little cluster. And both of those two clusters in Taurus, they'll become easier to see over the next couple of months as that constellation rises earlier and earlier. So it'll only be a couple of months now before it's up and about before midnight rather than after midnight. So let's turn to the planets. What have we got planets-wise? I mentioned last time that Mars is around the other side of the Sun from us at the moment. Well, it still is, so we can't see it. It's lost in the solar glare. It will return to our skies, though, in early December, when it will be low on the eastern horizon before sunrise, before the sun comes up. Now, we've got Mercury, which is just above the western horizon after sunset in the very first week or so of October. Just looks like a small, bright star after the sun's gone down, just over there in the west. But don't wait too long if you want to find it, because by the second week of October, it'll have dropped down below the horizon as it sort of continues its path around the sun. And the other 3 planets, we've got Venus, still nice and bright, high in the western sky after sunset. You just simply cannot miss Venus. It's just the biggest, brightest thing that's out there. And from where I am, at least in my latitude on this planet, we've got Jupiter and Saturn big and bright in the early evening and pretty much straight overhead, as seen from the latitude of Sydney, which is where I live.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.